Today we are going to discuss about trigonometric ratios. This is lecture number 29, part 2 of this lecture. In part 1 we have discussed about Pythagoras theorem. Now what about trigonometric ratios? We are going to study about application of trigonometric ratios in solution of triangles, and I will be discussing 4 types of problems that are basically involved in trigonometric ratios related questions. So, trigonometric ratio means sine of angle, cosine of angle or tangent of an angle. If this is a right angle triangle, then this angle is of 90 degree and the side opposite to right angle, this one is hypotenuse. Now, this is another right angle triangle and the side opposite to 90 degree is hypotenuse. But the problem is the side opposite to this angle theta is called opposite, and similarly side opposite to theta is opposite, and this third side is called adjacent. Same will be the case over here. So, the point here to be noted is that if you are going to change the placement of your angle theta, then your side opposite side is going to change. If theta is here, then opposite will be the side opposite to theta, and if theta is at this point, then side opposite to theta will be called opposite. And if suppose I am going to use this one as my angle, then this side will be called the opposite. So, this is important as far as the placement of the angle or consideration of the angle is concerned. So, these 3 are basically important trigonometric ratios. Now, we are going to apply them in question. In one type of question, they will be asking from you to find the opposite side. Find y. Now, in this triangle we know about the hypotenuse, the side opposite to 90 degree, and we know the angle. As I have told you that the side opposite to your angle which you are considering, right now I am considering this angle. So, side opposite to this is called opposite. So, sine 45 is opposite over hypotenuse, opposite over hypotenuse. So, from here you can find y. 8 will be multiplied with sine 45 and y will be 5.65 centimeter. Now, in second type of problem, you are going to find the adjacent side. Now, in this triangle, this angle is of 90, this angle is of theta, right angle triangle. Side opposite to right angle is hypotenuse, and we are going to find h. So, h is, in this case, it is adjacent, because this side is opposite to 30, we have got this one as opposite. So, this is adjacent. So, because we have to find adjacent and we know hypotenuse, so we are going to use cos 30. Cos 30 is adjacent over hypotenuse, and adjacent here is h while hypotenuse is 25 from the diagram. Now, you can find the value of h. 25 will be multiplied with cos 30 and you will get 21.650 as the value of h. In third type of question, you are going to find the value of angle theta, and we are going to use tan in this case. Now, in this triangle, a right angle triangle, you have been provided with the value of opposite and adjacent. Now, tan theta is opposite over adjacent. Now, opposite is 5, opposite to theta, and adjacent is 6. So, theta will be tan inverse 5 over 6, and tan inverse 5 over 6 will give you 39.80 degrees, the angle theta. And the last type of problem is to find, in this case we are going to find the hypotenuse. Okay. Now, in this diagram, this is a right angle triangle, this is 30. You need to find the side opposite to right angle, which is called hypotenuse. So, cos 30 is adjacent over hypotenuse. Now I am using cos 30 over here because I know the value of adjacent, and cos 30 has got adjacent in its ratio. So cos 30 is adjacent over hypotenuse, and adjacent is 4 over hypotenuse is to be obtained. So h will go over there, cos 30 will come over here. So h will be 4 over cos 30, which will give you 4.61 centimeter. So today in this lesson we have learned about the application of trigonometric ratios. In the next lesson we are going to discuss a law of sine and law of cosine for solution of triangles. Thank you so much.